All right, we're continuing with our belts, pulley drives, and sprocket chains worksheet. We're on the pulley drives, starting with number 10. So in a pulley system, pulley A is moving at 1500 RPM and has a diameter of 15 inches. Okay, 3 pulleys, B, C, and D, all of different sizes, are attached to a single output axle. Speed and torque output are changed within the system by moving the drive belt between pulleys B, C, and D. Okay, so first we want to sketch what's going on here. So our first one we have here, we'll call him A. Okay, we have his diameter. It's 15 inches. Okay, so that's the diameter of the input. It's 15 inches, and we have that the input speed from this A is 1500 RPM. And then it's going to connect to 3 other pulleys of different sizes to a single axle. So it's like down here at this other side. Let's draw him and draw them in different colors down here if we can. Okay, so we have 3 others attached down here. 1, 2, and 3. And they're all attached to one axle like this. And what's going to happen here is this belt is going to come off of here, and it can either go to here, to this small one, or we can move it up and go to this next one, or we can move it up and go to this one, and it will change the output speed coming out. So this is attached to maybe like a drill or something else, and we would change the speed of whatever's going out, or it could be a wheel or whatever. So it's just a gearing system that changes the torque and the speed coming out. Okay. Oh, and then it didn't really say which was which, so we'll call it, I think it was D is probably the biggest, and then C, and then keep track of my colors here, and then B. Okay? And so now on number 11. So number 11 is going to talk about B, so let's do him in this color. So a speed of 1750 RPM is required, so my output coming from B here is going to be 1750 RPM. Okay, so we're going to increase the speed we put in coming out at B. What is the diameter of pulley B? So we're looking for the output diameter. So we're going to set up a gear ratio where we have diameter over diameter is going to equal speed over speed. Okay, remember for diameters, it's out over in, and for angular speed, it's in over out. And we're looking for the diameter out, so we're going to resolve this thing and say that the diameter out is equal to the diameter in times the angular speed in over the angular speed out. Plug our numbers in. Diameter in was 15 inches. Angular speed in was 1500 RPM. And the angular speed out that we'd like to achieve is 1750 RPM. And when we do all that, we end up with 15 times 1500 divided by, oops, I did too many divides there. Well, 15 times 1500 divided by 1750. And we get 12.857, blah, blah, blah. Let's round it off a little. Let's go 12.85 or 12.9. Okay? 12.85 inches. And there you go. There's number 11. Number 12 says the speed of 2000 RPM is required by pulley C. So now we're going to look at pulley C. It's basically the same exact problem again. Okay, so the output that we want now is 2000 RPM. And we want to know what the diameter of that's coming out. We already saw we're going to use the same exact equation. We can say diameter out is equal to the diameter in times the angular speed in divided by the angular speed out. Okay, so the diameter in is still the 15. Angular speed in is still the 1500. Okay, we didn't change A. He didn't change anything. And then the output is all we've changed. So we're going to 2000 RPM. So plug all that in here again. So 15 times 1500, that's not times, divided by 2000. And now we get 11.25. Okay, so this one is 11.25 inches. And then we're going to do the same thing with D. It's the same problem again. Okay, speed of 3250. Okay, so my angular speed coming out now is 3,250. I'm still looking for my diameter out. It's still the same equation. Okay, so I'm not going to write that part down. I'm just going to put my numbers in. It's the 15 times the 1500 RPM. That didn't change. And that divided by the output, which is now 3250 RPMs. And when we do all that one, 15 times 1500 divided by 3250. And we get 6.92 inches. And there we go. Oops, sorry. Helps if I put it where you can see it. And there we go. That's 10, 11, 12, and 13. Okay? So let's look at 14, 15, and 16. They all have little parts. We'll see if we can get them all on this page. All right, so 14. For the following question, we're going to use this diagram right here. Okay, so it says, in what direction would pulley B rotate? So pulley A, well, let's see, I'm using the diagram. Pulley A is power source and is moving clockwise. So pulley A is moving clockwise. Okay, so he's going around this way. If he's going this way, that means my belt is moving that way, right? So if the belt is moving that way, if he continues around with B, then, right, if we take that arrow and come around here, then pulley B is going to be going counterclockwise. Okay, well, this is actually A, but it's pulley B. Okay, so that belt is still going this way, so that means this one's going to go around clockwise. The pulley C is going clockwise. Okay, and then that continues this way, and that's going to cause this one to come around going that way, which is still, pulley D is still going clockwise. Okay, so that's all we have there. On 15, it says, using the diameter of each pulley, what is the ratio between pulley B and pulley A? Okay, did they tell us the diameter of A? So let's squeeze 15 in here. So 15A, it says that the diameter of pulley A, okay, so we'll just call A diameter equals 6 inches. Okay, so now we need to set up some ratio here. So as we do this, our ratio that we're going to set up is just the output over the input. So the output is B, the input is A. So my gear ratio is just going to be diameter of A over the diameter of B. Okay, I'm sorry, B over A because it's out over in. Okay, so diameter of B was 3. Diameter of A was 6. So that's just 1/2 or 0.5 inches. Okay, part B. Now we're looking at C to A. So it's the same setup, right? So my gear ratio is still the diameter over the diameter, and it's out over in. Now the output is going to be C. Okay, so this is C, and the input is A. So now it's 10 over 6. That's 10/6, right? Or 5/3. Okay, so now when I don't know, 1 point something, 1.6, right? 5 divided by 3, 1.666. We'll call it 1.67. Okay. Oh, it's not inches up here. Sorry, it's a ratio. And then the last one, pulley D and pulley A. So again, the same setup. So gear ratio, it's the diameter out over the diameter in. The input is A. Now the output is D. Okay, so the D was 8 inches over A, which was 6 inches. So that's 4/3. Okay, which is 1 1/3, which is 1.33, right? And then what's 16 is? Let's see if we can squeeze 16 in here too. If the torque force provided at pulley A is 120, what is the torque at pulley B, pulley C? So we have to look at our setup with our gear ratios and setting up the gear ratio with torques. Okay, so now we know the torque at A, what did they tell us, 120 foot-pounds. So if we're looking at part A, we're looking at what is the torque at pulley B. So my gear ratio with torques is torque out over torque in. Okay, we're looking for the output torque, so we're just going to multiply. So we're going to say that the output torque is equal to the gear ratio times the input torque. And for this one, my input torque is 120, it won't change. And my gear ratio for this pulley B, right, we just did that here, was 0.5. Okay, so we're going to have 0.5 times my input torque of 120 foot-pounds. And so half 120, we're just going to get 60 foot-pounds. Okay, getting crazy in here. Let's use a different color so we can keep track of all our stuff. Okay, now we're looking at C. So we're doing the same setup, exact same setup. So we're going to have our torque out equals our gear ratio times our torque in. Okay, now our gear ratio is the 1.67 though, right? Because we're going pulley C. We're using that gear ratio we just solved for there. And so we're going to have 1.67 times the 120 foot-pounds. That one, I don't know. 1.67 times 120. And we're going to get 200.4. Okay, we could probably get around that to 200, but we'll leave it at 200.4. And then we'll look at the last one. Now we're looking at pulley D. So now my gear ratio is the 1.33, but again, the same setup. Output torque is that gear ratio times the input torque, which is 1.33 times the 120 foot-pounds. And we end up with 159.6. And that's it.